Hello, we're back with a new section of this video course, Process Domains and File Level Access Controls. In this section we'll work with file contexts and learn where they're stored. Then we'll try to understand how contexts are assigned, learn and obtain information about how and when processes get into their current context. We'll also see how to get a first taste of an SELinux policy and how to query it. We'll end with another SELinux feature called constraints and learn how they're used to provide the user-based access control feature. Now we move on to the first video of this section where we'll discuss about SELinux file contexts. In this video we'll learn how to get context information and interpret SELinux context types. When we work on an SELinux enabled system, gathering information about the contexts associated with the files and processes is a necessary basic capability. We need to understand how these contexts are used in policies and what the applicable security roles and access controls are for a specific process. Throughout this section we'll be using a web-based application development as an example, which is DokuWiki. This is a popular PHP wiki that uses files rather than a database as its backend system, and is easy to install and manage. So, let's start with getting context information. Let's assume that the DokuWiki application is hosted at DokuWiki directory within the htdocs and stores its wiki pages in subdirectories of the data / directory. This can be accomplished by downloading the latest DokuWiki tarball from the project site and extracting it in this location. Some distributions might have a different location for DokuWiki application, which is correctly labelled already. The example here generally follows the same labelling regardless of the distribution, allowing us to show various context-related actions. The contexts of files can be easily acquired by using the -Z option of the ls command. Most utilities that are able to provide feedback on contexts will try to do so using the -Z option, as we saw with the id utility. Let's look at the current context of the DokuWiki directory itself. So, type at the command shell ls-dz/usr/share/cups/www/dokuwiki and press enter. As you can see, the context displayed here is home_t. Later we'll change this to the correct context, as home_t is too generic and not meant for hosting web content. File and directory contexts are stored in the file system as extended attributes when the file system supports this. An extended attribute, which is often abbreviated to XATTR, is a key-value combination associated with the resource's inode. Each resource can have multiple extended attributes, but only one value per unique key. Also, by convention, extended attributes on Linux use this syntax. The namespace of an extended attribute allows for additional access controls or features. Of the currently supported extended attribute namespaces, the security namespace enforces specific restrictions on manipulating the attribute. If no security module is loaded, then only processes with the cap/sysadmin capability are able to modify this parameter. We can query the existing extended attributes using the getFATTR application, which I'll be showing you next. Let's write at the terminal getFATTR-m.-d dokuwiki. Enter. As you can see, an SELinux context is defined through the security.SELinux extended attribute. This ensures that the SELinux context of a file cannot be altered by non-administrative users when SELinux is disabled, and that manipulating context is controlled through the SELinux policy when SELinux is enabled. The stat application can also be used to show SELinux contexts. Let's use it now. Getting context information from a file or directory should be as common to an administrator as getting regular access control information like read, write and execute flags. Now let's look into interpreting SELinux context types. After using SELinux for a while, the motive behind using file labels becomes somewhat clearer. File contexts are named after their purpose, allowing administrators to more easily see whether a context is correctly assigned or not. Consider the context of a user file in its home directory, that is user home_t, a temporary directory in temp for a Java application, which is java temp_t, and a socket of RPC bind. All these files or directories have considerably different purposes on the file system, and this is reflected in their assigned contexts. Policy writers will always try to name the context consistently, making it easier for us to understand the purpose of the file, but also to make the policy almost self-explanatory. For the regular file system, for instance, files are labelled with a context resembling their root location. For example, we find binaries in the bin folder to be labelled with bin_t, boot files in the boot directory labelled boot_t, generic system resources in USR directory labelled USR_t, and so on. The more interesting labels are those for a particular application. For instance, for the MySQL database server or compatible databases such as MariaDB, we have these labels which are listed here. Based on the context of a file or resource, administrators can easily detect anomalies in the system setup. Cool! In this video, we've learned about SELinux file contexts.